Hello! In this video, we are going to prove the following theorem. Let a be a real number. If a is greater than 1, then for all positive integers n, a to the power of n is greater than 1. What was that? That was good. Okay, now to begin the proof, let's give ourselves an arbitrary real number a. And let's suppose that a is greater than 1. Now our whole goal at this point is to show that for all positive integers n, a to the power of n is greater than 1. And since we're trying to prove the same about all positive integers, let's use induction. So let's start with the base case. In the base case, we're trying to prove that this is true in the case where n is equal to 1. So really, we're trying to show that a to the power of 1 is greater than 1. And to see how that comes together, well, let me start out by writing a to the power of 1. Well, we know that a to the power of 1 is equal to a, and a is greater than 1. So, a to the power of 1 is greater than 1. And so what this means is we have shown that this is true in the case where n is equal to 1. So this completes the base case. Now let's go on to the induction step. In the induction step, we give ourselves an arbitrary positive integer n where this is true. And the whole goal of the induction step is to show that this is also true for n plus 1. So really, we want to show that a to the power of n plus 1 is greater than 1. And to see how that comes together, well, let's start out by writing a to the power of n plus 1. Well, we know that a to the power of n plus 1 is equal to a to the power of n times a. And if we take this inequality and multiply the positive number a on both sides, we get that a to the power of n times a is greater than a. And a is greater than 1. So as you can see, we have established that a to the power of n plus 1 is greater than 1. So what we've done here is we have shown that this is true where instead of n, we have n plus 1. And that was the whole goal of the induction step. So this completes the induction step. And because we've completed both the base case and the induction step, this closes the induction. Which means we have proven that for all positive integers n, a to the power of n is greater than 1. And putting this all together, we gave ourselves an arbitrary real number a that is greater than 1, and proceeded to prove that this is true. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.